Welcome back to Lesson 04 of our Python crash course. In this session, we explore the fundamental building blocks of the language, core data types, and basic operations. By the end of this lesson, you will be able to distinguish between numerical, textual, and logical data. These skills are the foundation for any statistical analysis or machine learning model. Python handles 4 main core data types. Understanding these differences is critical for numerical correctness and efficient memory management.
As you can see in the table, we have integers for whole numbers, floats for decimals, strings for text, and Booleans for logical true or false values.
Integers, or int, represent whole numbers without decimals. Python handles them with arbitrary precision, so you don't need to worry about overflow and standard calculations.
They are ideal for counts, indices, or categorical encodings. For instance, we can use integer 1 to encode male in a clinical dataset.
Floating point numbers, or floats, represent real numbers with decimals. It is crucial to remember that in computing, floats are approximations, not exact values.
Look at the terminal output. Adding 0.1 and 0.2 doesn't return exactly 0.3. This behavior is a classic in numerical analysis that you must always keep in mind.
Strings, or str, handle textual data. They can contain letters, numbers, and symbols, as long as they are enclosed in quotes.
Pay attention to the case below. If you write 10 inside quotes, Python treats it as text, not a number. This is a common pitfall when importing data from external files.
Booleans represent binary logic, true or false. They are the basis for every decision your code will have to make.
A useful technical detail. Internally, Python treats true as 1 and false as 0. This property is widely used in data processing and statistical modeling.
To write robust code, you must always know what data type you are working with. Type inspection is your first line of defense.
We use the type function to verify an object's class. As shown in the examples, the terminal instantly confirms if we are dealing with an int, a float, or a string.
The result of an operation depends strictly on the types involved. Python follows precise rules to avoid mathematical ambiguity.
Adding an integer and a float will always produce a float. However, using the plus operator between two strings will perform a concatenation, joining the texts instead of summing them.
In summary, data types affect mathematical correctness, memory usage, and the overall performance of your software.
Great analysts are obsessed with types because they know a 5-string instead of a 5-integer can silently break an entire workflow.
Great job! Lesson 04 is complete. In the next one, we will start making our code dynamic by exploring conditional structures.
Check the practical exercises on michellepierre.com to test what you've learned today. See you in Lesson 05.